Now we have something that I thought was really, really appropriate. For example, let's take, well, again, like you could say this about, you could say this a little bit about Rust, just a little bit. You could say this about maybe Zig a little bit in some cases. You can definitely say this about front end libraries like React. You could say this about Node, Electron, for example, Node, um, and Python. So, it's actually kind of difficult to find a study that looks at whether code that is abstracted in order to for the purpose of maintainability is actually maintainable. It's hard to find a study that's like that for like JavaScript land in general. But for Python, that's heavily studied because AI. So this is a study done in, well, this year, not too long ago. How maintainable is proficient code? A case study of 3 PyPy libraries. Python is very popular because it can be used for a wider audience of developers, data scientists, machine learning experts, and so on. Like other programming languages, there are beginner to advanced levels of writing Python code, and you can drop in kind of like any library or language that you want to pop in here. However, like all software, code constantly needs to be maintained as bugs and the need for new features emerge. Although the Zen of Python states that simple is better than complex, we hypothesize the more elegant and proficient code might be harder for the developer to maintain. Insert, wait, I got to do this right. Insert soy jack face, or as I like to do it, to study this relationship between the understanding of code maintainability and code proficiency, we present an exploratory study into the complexity of Python code on 3 Python libraries. Specifically, we investigate the risk level of proficient code inside a file. As a starting point, we mined and collected the proficiency of code from 3 PyPy libraries totaling 3003 files. We identified several instances of high proficient code that was also high risk, with examples being implist comprehensions, enumerate calls, generator expressions, simple dictionary comprehensions, and the super function. Our early examples revealed that most code proficient development presented a low maintainability risk, yet there are some cases where proficient code is also risky to maintenance. We envisioned that the study should help developers identify scenarios where and when using proficient code might be detrimental to future code maintenance activities. So then they go over Python, kind of like a little bit of a history, how it's used, the libraries that they picked, FPDF2, npm math, and PyTorch geometric. And so they break down what the libraries are and how they looked at the proficiency level. So safe versus risk, right? You can kind of see that there's a pretty good, correlate value here that you can infer. It's sizable. So have a look at some of the proficient calls. Simple list comprehension is an advanced level use case. It is risky. Enumerate call is master level. It's risky. Generator, advanced level, risky. Zip call, master level, risky. Super function, master level, risky. Now, the superfunction master level safe has way more cases of safe than risk, right? The simple list advanced safe has way more cases of safe than risk, and so on and so forth. So what they're essentially saying here is that it is not clear cut. It is not like just a straight up, well, every time that you use one of these more proficient or clever or abstracted tactics to implement your code, you're going to get the benefit of safer code because someone smarter implemented this thing that you now get to use. Interestingly, we observed, it's a very short paper, we observed that some cases with similar classes appeared in both the risky and safe categories. This suggests that even similar cases can result in either low or high maintenance requirements. It would be good to explore these findings in the future. So this is a small study based on only a few files, but you can imagine what it might look like if you take a vast swath of usage, not just in Python, but also like in JavaScript, for example. And I think actually this would be impossible to do in JavaScript. It might even be impossible to do in languages like Rust, maybe, where there's so much going on. You have so many interdependencies and so many things running all at the same time that you couldn't properly cover the spread, so to speak, right? But I thought this was a good one to just kind of highlight the fact that it's not as clear cut as you might think.